So I'm delighted to have Lars, who is actually from our Sydney office, here with us this week in Mountain View, and to be doing a talk on Wave for everyone. So this should be really interesting and also interactive as well. I wanted to kind of segue to Lars so he can introduce himself. Thank you.
Yes, hi. Thank you all for coming. My name is Lars Rasmussen. I manage the Google Wave team down in Sydney. Have you all enjoyed the conference so far? Good to hear that. Is this the last talk on Friday? Which means she either thinks I'm a really good speaker or she hates my guts. One of those. Alan is after. You hate Alan's guts. Okay. Oh. Okay, so I'm going to talk about Google Wave, which is a product. We haven't quite launched it yet. We announced it at our development conference a couple of months ago, and we have about 10,000 active users that are trying it out. It's really early times. Have you all gotten accounts on Wave? 1, 2, 3, lots of people. Okay, so you'll get a chance to try it out. In case you haven't noticed, these are still early days. It's still really buggy. It crashes all the time. At least we have funny error messages. By September 30th, we'll extend the preview to about 100,000 people, and it should be a little bit more stable by then. And then we'll do a real beta launch, hopefully later in the year, although we might slip into the next year. Has anyone here seen the demo we did at I.O.? There is a YouTube video, a few people. It's an 80-minute video. I'm going to squeeze that 80 minutes into about 15 minutes here, which you really shouldn't do. I highly recommend watching the video afterwards. Get some popcorn. It's apparently the longest video ever actually watched on the internet. At least that wasn't pirated. But I'll try and give you an idea what it is. I'll actually do 3 sections to my talk. I'll do a super fast demo of Wave. I'll talk a little bit about what we think is a pretty cool algorithm underlying some of Wave, since you guys are into that sort of thing. And then if we have time, I'll talk a little bit about some ideas that other researchers have had about how Wave might fit into your world. And then we'll do questions afterwards. So let me just buzz right in. Wave is a communication and collaborations tool that we have built. It contrasts with email, everyone's favorite tool, in that email sends messages. It essentially mimics snail mail. In Wave, we have the notion of a conversation of a Wave as a single shared object hosted on a server, in this case in the cloud, that the different users can manipulate. And I'll show you some of the advantages here. So I'm going to start a new Wave. And since you don't want to sit and watch me type for even 15 minutes, we have these canned messages here. I click a done button, and then I add my friend Dr. Wave, whom we will all be acquainted with like this. And now the Wave, the conversation is live on the server. It just has one message and these 2 participants. I'm going to just flip over to another window here where I'm signed in as Dr. Wave. I'll try and remember telling you when I flip over, but you can see who's logged in over here at the top of the contacts panel. Here's Dr. Wave. So Dr. Wave gets the barbecue wave here. And just like in email, he can make a reply here at the bottom and say, of course I will make it. You will soon see that I am the worst speller in the world. Like this. He can also go and reply somewhere interior to my message like this with an inline reply. It is always sunny down under, he says. There is my terrible spelling. Like this. So Dr. Wave can make replies outside and inside of my message. And those are conversations, and I'm showing you if I go back to my own account here, you will see that I now have those messages, and I can say, I knew you would, like this, and I flip really quickly over here. You can see that that message showed up immediately. Now, we also let users edit each other's messages. Here is, let me just see if I can get the right account. Here's Dr. Wave's account, and he can actually, even though this was my message here, he can edit the message and say he's a big chocolate fan, that he wants chocolate, more chocolate, etc. like this. And now he edited my message. If I switch back to my own account, you will see that that message now is bold, and when I open it up, we immediately show you the fact that Dr. Wave edited it, and a highlight of what happened here. So we let people edit each other's messages. I can edit my own message as well. And in fact, I'll show you now, and this is the algorithm I'm going to talk about later. If I add my two companions here, Jens and Dan, yeah, if you guys pop in and we can all edit this little thing together here, you can see that Dan is there. I'm editing up here saying wine. And Jens, are you in there? Jens is there as well. So now you can see the three of us can edit the message simultaneously. And you'll see that I can see what Jens and Dan are doing character by character. And in fact, if I just make this browser window a little bit smaller, you'll see that both I and Dr. Wave can see everything that's happening here. Dr. Wave sees where I'm editing as well over here. Pretty cool, huh? You guys, if you like it, you're welcome to, cheer, applaud, that sort of thing. So that's a really super quick overview of what a raw wave can do. You can do replies inside and outside of other messages. You can do editing of each other's messages. And you quickly realize that what before were two separate tasks of collaborating on content versus discussing things now actually becomes two ends of a spectrum. A wave we like to think of as the union of documents, collaborative documents, and conversations. You have a question?
Can you do context editing, for example, let's say code creation? If you're
Let me try and show you that later. Yeah, so we have some very powerful, we like to think, APIs on here, which is what we're trying to sell to developers now, that lets you configure the content inside a wave to something as specific as coding or writing an academic paper. I'll show that in a little bit. Okay. I want to first show you how we use this combination of conversation and document editing to construct design documents. Let's see if I can find a wave overview. Like this. So here's a little historic design document. This is actually the first document that my team produced with the tool. One thing, a feature we're very fond of is called playback, where you get to rewind the wave and see step by step as it was created. So you can see here that our trusted server guy, Steven, started with a terse draft here. You'll see it's a rich text document here. It's got headlines and bullet points and illustrations. And Lars, who's the manager, Steven adds the rest of the team. We were only 5 people back when this happened. Lars, the manager, says, you really need to do more work. Steven grudgingly adds a paragraph, says, yeah, whatever. We have a product manager who then goes in and edits the content here. She makes a comment down here, starts a discussion here, and so on. And so then we use this combination to construct these documents. You no longer need 2 separate tools, one to construct a document and one to debate it over here. And in fact, what often happens is that these little discussions here turns into a little thread. When we reach a conclusion, someone will go and implement the conclusion inside the document itself, and then you can delete the discussion. And again, because you have this playback mechanism, it's safe to delete stuff from a wave because you can always play it back and you can revert deletions. And so we find that a really kind of well-used wave often both grows and shrinks. Unlike an email thread that only ever grows, a wave will grow and shrink and grow and shrink. And every time you go through a cycle like that, you get a little bit better product out of it. Let me show you how, there's a little story we like to tell about how when we start using a tool like this, and we see this a lot, typically new users start using it as if it was an existing tool like email. So we've made the client look sort of like an email client to capture that familiarity. Let me just try that again. I mentioned how this was a little bit buggy, didn't I? Done. Pardon me while I reload my client. Here we go. Like that. Let me just add Jens and Dan. You guys seen that? Yeah? Okay, so we've had a lot of fun this week with indexes falling over. We made the grave mistake of actually inviting users in here, and they ruin everything. So we went through this. So we started using this very early in the year when it was really buggy, and we found that even though we worked on the tool for a year and a half, we started using it sort of like email. And typically, so we barbecue every Saturday down under, and someone would send out a message like this, and everyone would reply, and it became sort of a threaded thing saying, I'm coming, I'm not coming, I'll bring the wine, who can give me a ride, and so on. And when you're done with it, it looks just like an email thread, and it's really hard to extract a list of people that are actually coming. And so pretty quickly, someone had the bright idea, instead of just writing like that, then we would say, add your name to this list, and kind of outline a list like this. And that was all that was required. Now, instead of replying, people who were coming would actually go and edit this message here, put themselves on that list. And now when people would say, I'll bring the wine and who has a ride, that what happens at a discussion. But now automatically, at the end of it, you have the exact list of users. So very simple little change of the way we use this tool made us achieve the goal of finding out who's coming a lot simpler. And then, of course, since we're all programmers, we started realizing that there was a pattern of behavior here, and then we have APIs that let you target the content of a wave to a specific task. And I'll show you with coding later, but here it's the super important task of figuring out who's coming to the barbecue. And so one of the guys on the team wrote a super simple little gadget, we call it, which is now our favorite. It's called a yes, no, maybe gadget, and it looks like this. Yeah, and now all we have to do is click this link here. And now if you could see these guys' screens, are you guys seeing this wave? So you guys come in. So now you can see int clicks over here, and it gets transported over here. And now, of course, it's becoming even easier. You can even set a little status here. There you go. I can swing by late, I think, says Dan. And so this is a little gadget that got written. It's a totally standard thing, just like the gadgets you find on iGoogle. The difference is that because we put it in Wave, it becomes collaborative. When the state of this gadget changes, the Wave system automatically transmits it to other users. And using the same mechanism, which I'll tell you about in a couple of minutes, for concurrency control and automatic conflict resolution, this stuff just works. And now, at the end, we have, with even less work, this particular result that we're looking for. Of course, to show you another example, instead of just having a boring old address here, I can, this might actually break on me, but I can highlight this address here, and using a different extension, I can go and insert a map gadget like this. And now, again, without the programmer of this gadget having to do any particular kind of work, let me just add Dr. Wave again, like this. You will see, I'm having my fingers crossed below the podium, that when I move the map over here, it automatically moves for everyone else. When I change it to satellite view, I should have had all my toes crossed as well, shouldn't I? There, on a good day, then you can collaboratively use a map like that. Thank you. Now, don't be shy. It is Friday. Thank you. So you can now collaboratively configure this map here, and I can actually go and explain exactly where the barbecue is. Oh, come on. Jens put it over here. And so we can put markers and draw lines and so on. And again, this was very easy to write. We already have a maps API. We just packaged it as a gadget, and then the Wave system automatically takes care of transmitting all this data. And so we have, I should just say, since we're in this developer preview mode, we have a whole bunch of developers that are now building, these are all toys, but actually building real things, including folks on the actual maps team that will make this work for real. You guys getting busy yet? It's not quite like the Google Earth thing out there, but who knows, maybe we'll make a gadget with Google Earth in here as well. Okay. I will now show you, I should have written a script, shouldn't I? I will now show you how to integrate this with Twitter. So another type of extension here, actually let me show you pictures. That's what I want to show you. I'm going to start a new wave like this. And I'm going to say pictures. Did I mention my spelling is suboptimal? And I will go and I'll drag a stack of pictures from my desktop into the browser here, and they automatically gets added to the wave like this. Which if you're into browser application, you know that browsers can actually do this. And this particular feature actually requires Google Gear. So we added some modules to that to make this possible. And now if I go and I'll add Dr. Wave again, like this, I'll switch over to his account. I'll go check out his inbox. He's got these pictures here as well. And now I will add some more like this. And so now Dr. Wave and I have collaborated on putting together some pictures. You'll see that I have, oh dear, you'll see that I should have his pictures here too. Imagine that those gray things were actually Dr. Wave's pictures. Now I get to go view a slideshow, and if this hadn't broken, then I would be able to see both my pictures and Dr. Wave's pictures in the slideshow here. So Waves can be used as a super easy mechanism for collaborating to put together photo albums. Are you guys familiar with Murphy's Law of Demos? And the success, the chance of success is inversely proportional to the importance of the audience. In other words, it's your fault that everything is breaking. Like this. So now we have these pictures, and I want to show you another extension that we built as a little toy, but these is done with third-party APIs that anyone could use. I will add what we call a robot, which is a server-side piece of software. It's a web service that interacts with the wave just like a human can do. So there is an API that lets this robot, which sits on the server, see all the live changes, inject live changes, add and remove participants, and so on. This particular robot doesn't do a lot. I'll show you different robots later. It just does one thing. It publishes this wave. So it gives the world access to the wave, and then it takes and uses a different API to embed this wave on my blogging site. And so now I'm going to go to my blogging site here, and then you will see, so this obviously was supposed to be, hang on a second. You'll see this is actually completely frozen, isn't it? Okay, ignore all the errors here. Look forward to a good weekend. So this should be the right pictures, but you'll see that the pictures embedded here, we didn't actually just grab the pictures and copy them onto a web page. We've embedded the entire wave with all of its UI onto this page here. And so suppose I wasn't myself here, but some of my many fans that read my blog religiously, I could now go and use the Wave UI embedded on this blogging site here to make a comment. Nice pictures. Holy mackerel, I can't spell. Nice pictures, in particular the gray ones, like this. And then if I go back into my Wave client, you will see, remember this is just a single shared object. And so even though someone made a comment on my pictures on the blog page, because it's a shared object, that comment shows up inside my Wave client. And so I don't have to go back to my blogging site to manage my blog. I can do it all from in here. You are so right about that. Anyway, I really do this to show you our little spell checker. Like this. You like the spell checker? You want to see the bean soup demo? Let's see if we can make this work. Can I have some bean soup? You notice that I'm purposefully hitting a correct dictionary word, and still our spell checker checks and realizes that I'm in bean soup. It sometimes also suggests beer soup. It has, now I'll do it in reverse, it has been so long, and again it figures out that I'm in bin. We've actually turned off a really cool feature where sometimes our spell checker, which obviously is contextual and uses the entire web to learn a big language model and so on, it sometimes has such good confidence that it autocorrects the word. And so just a few words behind you comes this really nice thing and fixes up all my errors. that are numerous. Anyway, that was a little aside. Our spell checker, apart from all of the magic it does with language models, is also written with this robot API. It's a robot that automatically sits on all of your waves. The last thing I just want to mention, if I can find the right spot here, if, I don't have enough people here helping with the demo, if the person who made the comment here hadn't been me, but another wave user, the fact that they had made a comment on this wave here would make the wave automatically show up in their wave inbox as well, which means that they also don't have to go back to the blog site to wait for me to reply to their question. It'll just pop up to the top of their inbox when I make that answer. And so we have this idea that there'll be waves sitting everywhere on the web, and you'll go and engage in these conversations. And you can aggregate all of the conversations or waves you're interested in into your inbox, which we estimate will make Flame Wars about 300% more effective. You guys don't do Flame Wars, come on. You're not supposed to even know what that means. Okay, so I want to show you just a couple more extensions before we go to the next section. I'm already way above time here. So since you asked about source code, do you guys have a snippet of Python handy? Because I don't actually program. I'm gonna start a fresh wave here. I'm gonna add Jens, and I'm gonna add Dan. And if one of you guys want to just pop in, I'm gonna add another robot called K-Syntaxy. And let's see if we can make this work. Pardon the mess here. I think I can't even spell Python here. Is this gonna work? Is this gonna work? Is this gonna work? Is it gonna work? It's not gonna work. It's your fault. Try it again. Remember the Python thing. Anyway, on a good day, what would happen here is that the robot, K-Syntaxy, sees that there's Python code in here. It grabs it on the server, matches it up against the syntax coloration. There you go. You saw here that even though Jens pasted plain text, the robot here now formats it as Python. And I don't know if you can see this on this projector here, but the keywords here are in a slight purple color. If I go and delete the B here, then it turns black. And the way this works is that the live changes I make gets transported through our server to the robot sitting somewhere else out in the cloud. And the robot then sends back a command to turn that black. And if I now reverse that, it does the opposite on a good day. And this is not a good day. There we go. It takes a little longer. And in fact, you could write a robot that then, so this one just the syntax coloration, you could write a robot that takes and executes the Python code here and then puts the result, in this case, in the wave. But the sort of one of the holy grails of extendability of wave is that you should be able to write a full-fledged IDE where you do all of your source in here. We'll even write a debugger so that you can sit and collaboratively single step through code that gets executed by the robot sitting in a central location. The benefit of doing something that crazy would be that now your coding becomes collaborative. And you can use all of the discussion mechanisms to do your coding. Yes, sir?
So how does this interact with, say, the file system? I mean, if you want to run this on your local computer or if you're writing LaTeX into file or so on.
So you would then put your robot on your local computer. The robot doesn't have to sit locally. So that would cost sort of an extra round trip time, and we might make it so that you can circumvent that by putting a little mini server on your machine as well. Now we're getting way too deep into this for my 15-minute demo, but the underlying protocol of Wave we've published that. And so there is a site called waveprotocol.org where you can see how it works. We've slowly started open sourcing all of our code. We're promoting the protocol for other entities to build Wave servers, including competing ones. And you'll be able to build just a mini one that sits on your own machine so that you don't have to go out to the cloud. And also so that you can, if you're keen to have your Wave sitting close to you for whatever reason, you can do that by just taking a Wave server, putting it in the closet, and then the protocol will manage communication between different servers if the participant on a particular wave belongs to different providers. Yes, sir?
No, the playback feature you have shown is based on a linear history. Any support branching like Visual
So currently we don't control, it's not quite linear actually. We kind of unravel when people do things concurrently. We unravel it a little bit. We are planning, and this is not going to be anytime soon, but we are planning to have ways. I'll show you just a little example. Let's see. I showed you that design document before, didn't I? Dun, dun, dun. Where did it go? There. So here, imagine we're now feeling we're in a good state with this document here. So the one feature we do have at this early stage is that you can now grab the product of your work here and copy it into a new wave like this. So now in this new wave here, you just get the current state, which is the product of your work, and you can keep working with it in here or share it, put it on a blog, whatever. The long-term intention is that this is just a copy now in a separate wave. The long-term intention is that this new wave here becomes linked to the old wave with a pointer back to the version at which it was created. And then the algorithm that I'm going to tell you a little bit about in a second will make it possible for you to go back into the original wave, do more work, and then merge your changes into the new wave, even if that new wave has changed. And the algorithm we work with does automatic conflict resolution. I don't have time to give you all the details, but we'll even make it, and this is obviously inspired by source control systems, we'll make it so that you can have a set of, we call them work waves, pointing to the same product wave. You go with a team and do some collaborative work in one, you merge your result into the shared product wave. Everyone else can pull those things into their waves, merge it with their local changes, and then put theirs up when they're done. I would love to sell this kind of thing to a site like Wikipedia and so on. I think it'll be a very, very powerful thing. Okay, let me just show you the last little, actually 2 more robots that I'm going to squeeze in here real quickly. You guys all use Twitter religiously? That was a question. Of course. Good. So we built a little demo robot here called Tweety, the Twitbot. You add it to a wave and it immediately pops a form into your wave. So waves can contain forms. In fact, the content model of waves is very extendable. And I can now sign into my Twitter account here like this. And now the robot goes and uses my, there we go, and uses my password to log into Twitter and grab my tweet stream like this and pop them in this wave. And you'll see that now I get to read them, and as you see, because it's now in a wave, it keeps track of exactly what I read, and so on. And I could just keep this wave around. We haven't actually built it into the Tweetbot, but it could continuously poll Twitter so that every morning I'd see my new tweets here, and I know exactly which ones were read, and so on. And now let's see if there's a interesting thing out here. This is my colleague back in Sydney. She's about to go home and drink wine. And so I can use Wave to reply to her as I drink one for me as well, please. She'll know I'm demoing Wave when she sees this. And so I'll make this reply. And so I've done this inside Wave. And what happens now is that the Tweetbot sees that I made this reply, and it goes over to Twitter. And if I just refresh the page here, you'll see that the Tweetbot put this out into my tweet stream like this. Yeah, and so this is an example of how you can use robots. I showed you earlier you can use robots to publish stuff. You can use robots to Twitter, but this could email you use for communication. Our vision is, of course, that if we can actually sell these APIs to programmers, and I mean you guys, of course, then you should be able to use Wave as a central hub for all of your communication and collaboration. Okay, last thing, did you guys attend the wonderful talk about machine translation the other day? So someone from that team very kindly built a little robot called, oh snap, that's right, called Rosie. This is not looking promising. The chances of this demo working, not super high. Let's see if we can figure it out. So I'm going to start a new wave, and I'm going to add Dr. Wave, and I'm going to add Rosie. And I'm going to start a new wave. Or maybe I'll proceed to the next part of the, the talk. Okay, let's try it. Dr. Wave and Rosie. And I'll give myself a little bit more space here. And then we'll see. Everything's broken over here, isn't it? That was the best part of the demo, too. Always is. Dun, 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 dun. You have gone incognito. Sandbox. Dr. Wave. Logging in. This is well worth the wait, I guarantee it. Good question. I mean, good idea. I accept bribes of all kinds for access to the sandbox. Yes, absolutely. In fact, if you have a name and email address, I can add them after this talk. It shouldn't be a problem. No. You will have to do without the Rosie demo. Sorry about that.
So do you have a text robot?
Pardon me?
Do you have a robot to build a text document?
You're going to build a robot? Then I can't quite hear you. It would be very extremely possible to do, actually. In fact, if you're into that sort of thing, I'd recommend you go look at Google's chart server, which has the ability to take a little LaTeX expression and return an image of a formula, for example. Let's see how is it looking over here. Who knows, maybe it will work after all. I'm not sure. Okay, now it can't possibly fail. So I've set up a wave between myself, Dr. Wave, and Rosie, the translating robot. And if I type hello world, it kindly translates it into French. Bonjour le monde. Wow, this is a wonderful demo. Yes, and so you'll see that Rosie actually translates word by word what I'm saying. And if I go back over here and reply in my only French here, then you'll see that it translates it back into English. And so this excites us a great deal, actually. And it's not just because it makes things like flirtation a lot more efficient, but you could imagine, you could also use this. And so the guys from the folks from the research team that built this, they have this vision that excites me a lot, where you could have two people collaborate on, say, a research paper that don't speak the same language. And was that good luck? They never speak the same language. Okay, so the idea is this. So Rosie, if you heard the talk yesterday, it uses statistical methods to translate. And so you train it by feeding it pre-translated documents. And it's not perfect. But you can imagine something like this. I write a draft of a document in, say, English, add Rosie, and it gets translated to Russian, but somewhat broken Russian. And I add my Russian collaborator who doesn't speak very well English. But it's good enough Russian that my Russian colleague can go and fix up the translation first, and then go and add his pieces to the collaboration, which will then be translated back into broken English over in my world. And I'll go and say, okay, let me fix this translation into English. And I say, and now I'll add my things, which then gets translated into broken Russian. And so these guys believe, and I think it would be a wonderful thing, that you can then actually end up with a collaboratively constructed document about something, even though the two collaborators didn't speak the same language. And you have trained Rosie, the translator, in the process so that she'll do better next time. Pretty cool, huh? Okay, so that's all the demo I'm going to show you today. I think I mentioned that there is an 80-minute video out on the web on wave.google.com. Get yourself some popcorn, comfortable chair, watch it. The best parts are in the end, and you can't fast forward. Okay, rapidly running out of time here. I'm going to tell you, so I think this ability to edit the same document at the same time, seeing character by character changes, while having an extendable content model is a pretty good thing, and we're proud about the algorithm. I had nothing to do with this. A couple of the folks on my team did this work. Alex Ma in particular, David Wang, Søren Lassen, Christian Oller. Lots of people were involved in this. The method we're using is called operational transformation. It's a style of algorithm. Has been the subject of quite a lot of academic research. The particular paper we started with is called High Latency, Low Bandwidth Windowing in a Jupyter Collaboration System, written by these 4 gentlemen here. 2 of them actually work for Google now, and they've been very helpful, Mike and John. It came out of Xerox PARC in the mid-90s. And here's a very brief description of the problem. So there are 2 clients and a server. And the clients have their own copies of the document. And if I hit an A over on this client here, of course, we want to display that A immediately and then send an operation on the wire that explains where I inserted that A. Right? And now the 2 documents are out of sync. Right? And then the operation travels through the server, gets applied over here, and now we're in sync again. The challenge comes when 2 people are working simultaneously, that now they both get out of sync and operations cross each other on the wire. And we want this property called optimism, that everything that happens on a client immediately gets displayed to the local user, and it doesn't get reverted unless it has to. We don't want to go and wait for round trip time and so on. And when there are conflicts, we want it to be resolved automatically. And here's how not to do it. So imagine the 2 documents is a string A, B, C, D, E, and on one side, actually, let me back off a little bit. So the really nice observation the Jupyter folks made was that if you have a centralized server, rather than doing it in a peer-to-peer fashion, then the algorithm requires only to know about 2 endpoints, 1 server and 1 client, and the server kind of duplicates the same algorithm with each client. And once it has resolved an operation from 1 client, it pretends to all the other clients that operation originated on the server. And that greatly simplifies matters. And so from now on, we'll just talk about how the algorithm looks between the server and 1 client, and we'll claim that an operation came from the server when in fact it came from one of the other clients here. So let's say that on the client, the user deletes the D and the server decides to delete the B. And so in one direction comes delete 4, and the other direction comes delete 2. If you just naively apply them, of course, you end up not having the same document, which is what you don't want. And so instead, you do this. When the delete 4 arrives on the server here, the server knows the version that this operation originated from. And so when it arrives here, the server knows that delete 2 was applied to the document in between the version of origin and the version you want to get to. And so the server transforms this operation against this operation here, and it turns into a delete 3. And now the server ends up with the string ACE. On the client, we do the same thing. When delete 2 arrives here, the client knows that delete 4 was executed in between the originating version, and now it does a similar transformation. In this case, it's the identity, because the deleted character here was passed to deleted character here. And now we end up with the same string. And so this type of algorithm is called operational transformation. The trick is to describe your data structure, which is in our case is an XML document, describe a set of operations by which you manipulate that data structure, which I'll talk about a little bit later. And then you need a transformation function that takes any 2 operations, S and C for server and client, and produces a set of operations S dash and C dash, prime, I mean S prime and C prime. It's been a while since I've talked about algorithms. And it has to have the property that for all pairs of operations and all documents, applying C prime followed by S and applying S prime followed by C have to land you with the same document. And so the the tricky part here is to come up with the right triple of data structure, operation set, and transformation function. It's easy to see that there is a good range of choices of transformation function even when you've locked in the two others. For example, you could fulfill this property here very easily by having all S primes and C primes just delete the entire document. Right? Then you would have this convergence property, but users are probably not going to like it too much. And so there's a little bit of an art here in encoding this triplet here in a way that preserves the intention of users. And so this was the work. Here's another way of describing what happens here. The document on the server and client goes through this state space. It's a two-dimensional state space where the first dimension describes operations that originated on the client. The other dimension describes operations that originated on the server. And then the solid lines here tell us the path that the client traverses through the state space here. And the dotted line tells us the path that the server traversed through the state space here. And this is how we draw the example I showed you right before. The originating string here, we give that version number 0, 0. And then simultaneously, the client goes left, the server goes right, like this. And then a little bit later, this operation here arrives over here. And moving here down to the parallel spot here is transforming S against C. And likewise, moving this arrow down to here is to transform C against S. And then you end up in the same state. So this is just another drawing of the example I just showed you. Of course, the trick is that, one trick is that server and client can diverge arbitrarily many operations. And so here's an example where the client has executed two of its own operations by the time an operation arrives from the server. And so here what you do is you do two transformations against first this one and then this one in order to get down here. And so one of the drawbacks of this algorithm here is that if the client and server diverges quite far, the complexity of catching up is multiplicative. And so if you have a large divergence here, the getting back together here, if there's n outstanding operations here and m here, then the complexity is n times m, which can be prohibitive if you have offlining. And so we made what we like to think are some advances. At some point, we'll probably try and publish an actual paper about this when the dust settles. One simplification of the algorithm we made is that when the client sends an operation, it holds off on all the other operations until an ACK comes back from the server that has received the first one. And so this dramatically simplifies the amount of state the server has to hold. Of course, in a very high latency situation, it makes it a little slower for operations to arrive in the other side, right? So what happens if I'm typing really fast, I send the first character on the wire, but then I've typed 3 more characters before that ACK comes back, and then I send those 3 in a single go. Whereas if we had done the additional work and kept the additional state on the server, then those 3 operations could be chasing each other on the wire. And the algorithm would still work, but it's a lot harder to maintain. We also added some recovery logic. I think probably anyone who's actually implemented this algorithm for real, including the 4 authors who actually built a really nice system called Jupyter, have put in there. So another thing we did, and this is again about constructing that triplet. I'm running out of time, aren't I? Constructing that triplet, we made sure our operation space is closed on the composition. That has a very nice effect that if you have that NM outstanding thing, as long as you can compose them efficiently, then you can also transform them efficiently. I think the time complex in the end becomes n log n plus m log n, which of course is a lot better. And you get lots of other benefits, but you'll have to wait for that paper to come out. It'll undoubtedly be written in Wave. Questions? Yes.
Well, of course, there could be lots of potential applications of this. There is one that could be potentially very influential, which is helping for developing the semantic web. The semantic web, which has been a tremendous failure so far. And using Wave, I think that collaborative collaboratively enriching websites could be possible in such a way that users contribute some semantic content to sites even if they don't own the site themselves. So that could be a very good opportunity for helping the development of the semantic web. What do you think?
I think you're absolutely right. Of course, any application you propose to me, I'll say you're absolutely right. But I do actually mean it. What we found is that collaboration, it's just like with a computer. If you have a certain task for a computer, if you only have one computer, it takes so long. If you can get 100 computers to do it in parallel, it works a lot better. And if we set this stuff up right, we can collaborate on all kinds of tasks, and it just makes more stuff done. The missing part here is the integration. And so we believe we have all of the APIs to make that happen. And if we don't, we'll add them. And then it's just up for you to write that thing, where by you, of course, I mean your students. Yes? Yeah. Yes. Look, seriously, I mean, it is our, you're not supposed to be everything for everybody. So we're trying to be everything for everybody. It doesn't necessarily have to be quite that dramatic for us to consider ourselves successful, but it'd be very nice. So I certainly much enjoy when I can do tasks I used to do in a whole set of different tools that were poorly integrated, when I can now do it all inside Wave. There aren't that many things in my life that I can do that with, because all of these integration points are not done yet. But that's what we're hoping. Another way actually of describing Wave, so I've shown you mostly an application, I've shown you a little bit of a platform to build different things with, but in a sense Wave is a programming model as well. With this algorithm I barely had a chance to outline. Wave is really, in essence, an XML document. I simplified a little bit, and the Wave client is really just a thing that knows a particular schema and displays it in a certain way in a web browser and manages certain interactions with users. But we keep adding new types of contents, and it's really easy to add stuff, and then you respond to user interactions, and it goes on the wire and automatically gets resolved. The algorithm is very generic. Like you don't have to know too much about how it works in order to design new types of things like the form elements, radio buttons, any kind of thing. And we've seen lots of suggestions from researchers about trying to integrate scientific tools into Waves. And it would be very easy to display kind of a control panel from a tool and make it all collaborative. Yes.
So one of the difficulties, it seems, with a lot of social media is often understanding the visibility of the behavior you do. If I make this comment, is this globally readable? Is it not? And so one way you kind of, it seems, done that is you explicitly know, go to a website, I kind of see some different things I know it's associated with this website. So in Wave, you have this nice personalized view, but in some sense, you've aggregated all these different interactions onto this one perspective. I was wondering if you had any thought about how you could kind of better expose to users kind of the visibility of their changes, or if they kind of understand how they'll play out. I mean, it seems some sites like social networks like Facebook have attempted to have people set up different groups for even commenting, and that has so far been a pretty big failure, at least on that website.
Yeah, so this stuff, I could tell you what I think about it, but really this is stuff I think has to play out when we get actual users. And we've already seen our original super simple, you add individuals one at a time, didn't work super well already at the scale of just a few thousand users. People quickly wanted very strongly to have groups. And we have groups in Wave, actually. We just don't have an interface yet by which you can manage groups. And so we offered all our users to be part of one big group, which had the super exciting effect that everyone starts a Wave with everyone. And then they say, oh my God, this is cool. Are you there? Can you hear me? And that's why it's not working very well right now. But we'll figure that out. One of the things we're going to do is to make the construction of groups something that robots can do, and also something that people can collaborate about. We have kind of this theory that if something isn't a Wave, it probably should be. answer to you again. And so the way you construct a group is you take a wave and you write in all the participants of that group. And that immediately makes it available to robots to construct groups, say by syncing them up with groups over on Facebook or in an LDAP directory. But it also means that users can collaborate on putting together a group. And we have high hopes for that, but we haven't actually built it yet. So. What's that? What does it mean to erase a wave? Why would you do? Oh, no, I'm just kidding. So you erase a wave by removing all the participants, and then we'll garbage collect it for you. Removing a participant is one of the features we haven't quite implemented yet. There are some subtle issues with deleting a wave. Removing a participant because it's a sort of shared object, and so there's some conflicting desires here. You want to remove people, and typically you probably want to be removed if someone else wants to remove you, because we try to optimize for the case where everyone has the same interest, and then put in safeguards to prevent abuse. And so the rule is that if I add you and I remove you before you've opened the wave, you never find out about it. However, if I add you and you have opened the wave, then I remove you, to everyone else on the wave, it looks like you're just gone. And when we add more stuff to the wave, you don't get to see that. However, because you'd opened the wave, when you go back to the wave, you get to see everything still up to the point where you're removed, and you get an option to save a copy. And so you go through all that, and then when everyone has been removed, and there'll be just a handle to remove everyone, then we can garbage collect the wave. Of course, someone might have saved a copy. We very carefully don't disclose to the other participants who saved the copy, or even if they got the opportunity. Yes?
Yes.
Oh, sorry. Someone has the microphone. Microphone wins.
One of the problems with texting is, of course, the lack of non-text context information for your exchange, yes. Visual cues and what have you. Have you thought of using the wave technology to add additional out-of-band communication mechanisms?
Like, give me an example.
You could get a feedback of we speaking longer on the exchange, or you could get you could react on with emoticons on on the side.
Yes, gotcha. Yeah. So the idea would so typically today we're actually running out of time. Whose time when I take it? Alan. Where is that? Is Alan here?
Alan's here.
This should probably be the last question. It's way over time. Oh, he's on the phone. Good for us. So oh, there he is. So the idea of robots is that you can build all that stuff in there. I mean, already you can throw pictures in there, you can throw documents in, you can do rich text, and it's as live as texting is. Let's maybe talk afterwards. Alan, it's all yours.
Okay.
Yeah?
Thanks, Lars.
Thank you.